All right, so this is Chapter 6, Section 6, Remainder and Factor Theorem. The learning target, I can use the remainder and factor theorems. The first part, synthetic substitution, is just basically a process to evaluate functions. And these are polynomial functions, so they're going to be a little bit more in depth. But yeah, so here the remainder theorem as well. Basically, the remainder theorem is when you have a number that you want to evaluate, we'll call that C. So C is the number we want to evaluate. So we have f of C that is equal to our remainder when we do synthetic division. So I'll finish right that. But basically, when we're evaluating C, so f of C equals R, that's the remainder of synthetic division. So let's do a couple examples first. First example, f of x equals x squared plus 6x plus 5. And I want to find when x is 3, so f of 3. That is what my goal is to find. So I'll just move the paper up. So my goal is to find when x is 3, basically what is f of x or what is y. So to do that, whatever this number is, it's going to go in the backwards. Oh, we were just doing synthetic division right now. So this number goes there. You then, like synthetic division, are going to find all the coefficients, all the numbers in front. So we have 1, 6, and 5. Leave a space here for the synthetic division part. Again, first part, drop down that first number, whether it's a 1, a 2, a 3, or a 4. In this case, it's a 1. And then I'm doing 1 times 3 is 3. I combine 6 and 3 to get 9. 9 times 3 is 27. And I combine 5 and 7 to get 32. 32 is then our answer. So f of 3 equals 32. What does that mean? When x is 3, y is 32 is one way you can look at it. This part right here, right, if we were doing total the synthetic division, we have 1x plus 9. That is called the depressed polynomial. It's the polynomial you get after you do the synthetic division. Just keep that in mind for the examples down here. All right, so there's one example for you. I'm also going to give you one more example that's a little bit more rigorous. All right, so I'm going to bring it over here now. We have f of x equals x to the 4th minus 3x to the 3rd plus 2x squared minus 2x plus 6. And we're going to evaluate this for f of 2. All right, so here's the polynomial, and I want to evaluate, I want to find f of 2 when x is 2. So, backwards L again, I have the 2. And then I have 1, negative 3, 2, negative 2, and 6. Right down there. And again, it's the same process. So I have the 1. 1 times 2 is 2. Negative 3 plus 2 is negative 1. Negative 1 times 2 is negative 2. 2 plus negative 2 is 0. 2 times 0 is 0. Negative 2 plus 0 is negative 2. Negative 2 times 2 is negative 4. 6 plus a negative 4 is just 2. So again, my answer, f of 2 equals 2. What does this mean? Again, when x equals 2, y equals 2. And my depressed polynomial would be 1x to the 3rd minus 1x squared plus 0x minus 2. Again, that is what the depressed polynomial is here. This, again, is not the answer. The important part is this part right here. All right. So that's one chunk of what you will have to do. the evaluating chunk. You will also have to be given the second part, which we're going to talk about these examples here. This is where basically you're given a solution already and you are asked to find the other solutions using synthetic division. So, the first example I want to give you, the directions in your book or in an example is going to say given a polynomial and a factor, find the remaining factors. Okay, so we're going to have two examples. We have example here, example here. Okay. So this first example on the left, you're going to have x to the third plus 2x squared minus x minus 2. And then in your book makes a semicolon and then says x minus 1. What this x minus 1 is this is a factor. This is going to be a solution. I could take this and take x minus 1 equals 0. I get x equals 1 when I add 1 over. This then is the number that we are going to put in our backwards L for synthetic division, is just that 1. Again, in front of x to the third we have 1, we have 2, we have negative 1, and we have negative 2. Same process as before. So we drop this down, we have a 1 here. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. Negative 1 plus 3 is 2. 2 times 1 is 2. Negative 2 plus 2 is 0. This right here, getting this 0 as a remainder, should happen. They're telling you that they're giving you a 0 that they have already found, and now they want you to find the other remaining zeros. This is our depressed polynomial, so we have 1x squared plus 3x plus 2. Then to find the other ones, you either have to use two methods, either the quadratic formula or 2 factoring. Right, if it factors easily. Again, I'm looking for two numbers that multiply to 2 and add to 3. That's going to be x plus 2 and x plus 1. I then can equal these both to 0, so I have x plus 2 equals 0 and x plus 1 equals 0 to get that x equals negative 2 and x equals negative 1. I should have 3 solutions. I started with an x cubed. I should have 3 solutions, which I do. Let's go to the next example. So this next example, we have x cubed here minus 6x squared plus 32. And they're telling you, hey, x minus 4 is already a solution. It's a factor that will yield a solution. So I can go x minus 4 equals 0 and get that x equals 4. That again is the number that's going to go in the backwards L. I have a 1, a negative 6, a 0, and a 32. Again, we're missing where x is, right? It goes 3, 2, and then we skip x. So we need to import that 0. I'm then going to drop the 1 down. 4 times 1 is 4. Negative 2. Negative 2 times 4 is negative 8. 0 plus negative 8 is negative 8. 4 times negative 8 is negative 32. Again, we know that this is a solution already, so this should be 0. And I have 1x squared minus 2x minus 8. Again, you can do factoring here, or you can do the quadratic formula. I'll write the quadratic formula in the space that's up here in pink. So the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. You could do that here always, or else again you can factor if it works out well. I'm looking for two numbers that multiply to negative 8 and add to negative 2. in this case, I have x minus 4 and x plus 2. Right? Negative 4 and 2 multiply to negative 8. Negative 4 and 2 add to negative 2. And again, I can find the final answers. X minus 4 equals 0, and x plus 2 equals 0, where x equals 4 and x equals negative 2. Again, I have my 3 solutions. Sometimes they might double up, but I do have 3 solutions here. If you can't find something to factor, you can always use the quadratic formula. Just make sure that you know that the first part is the A, this is the B, and that is the C. Again, it's one or the other. Other than that, are all the examples that you will need. So, if you do have any questions after you watch this, do ask me in class, or send me an email, or tweet me, or any other sort of way.